absolute value of x plus 1 equals, it would be x squared minus 11. And then, so I'd do x plus 1 equals x squared minus 11. And then I would do x plus 1 equals negative x squared plus 11. So change the sign on both. And then I want to get everything to one side. So on the left one, I'm going to move it to be with the x squared. So I keep that positive. So I get 0 equals x squared minus x minus 12. And that's x minus 4, x plus 3, and 4 and negative 3. On the right, I want to move it the other direction. So again, the x stays positive, x squared. So positive x squared, negative 11, and I get x squared plus x minus 10. And there's no factors, right? So you got to do the quadratic equation. So a is 1. B is 1, C is negative 10, negative B plus and minus the square root of B squared minus 4, A, C, all over 2 times A. And I get negative 1 plus and minus the square root of 41 over 2. So your answer's, oh, just because... Did you have a negative 11 there? So that one doesn't work. The other two were fine. Negative 1 plus root 41 over 2, negative, that's fine. Maybe, did you use like the minus sign instead of like the negative on the little, otherwise I don't know what that means. So these you would want to plug in and check. And the negative 3 won't work.
Can you plug in like the square root fraction or no?
Can you plug that in?
Yeah.
Yeah, that's fine. Like it will read this the same as that. Okay. It shows it as it taken out, but it's just weird. Like this looks a little weird. I don't know. No, it's this, whatever that thing is there, that looks like it's weird. Okay. So don't stress about that, but that negative 3 doesn't work. Right. So just be careful. And that you did negative 11 instead of the negative 3. So just be careful there.
Okay. Thank you.
Yeah. No, you won't have to. No. Dustin?
Can you use quadratic equation even if you can still factor it?
Yeah. Quadratic works on anything that's x squared, no matter what. It's the only thing that works no matter what. Yeah. Richard?
So if the answer looks like that, you want us to put it in a calculator or?
So this, don't worry about, okay? There's nothing on the test that's like that. That's not going to work. These, you definitely want to check. Yeah.
For my number 13, it also had like the radical thing, but only one of them was right. Like it was negative 1 minus radical 73, but the plus one wasn't right. So how would you know?
Okay. I mean, you'd have to plug it in, but that's not going to happen on your test. Yeah. You would have to approximate it for the most part if you didn't have a calculator, but don't stress about that. Yeah. That's absolute torture. We like to live right near absolute torture, but not in actual torture. Okay, so 1-7 is next, okay? The good news is this is relatively easier, okay, than what we saw yesterday, especially at the end there. So you're going to learn about interval notation, which should be new to you, but everything else really should be review, okay? We're switching gears, and we're talking about inequalities. So inequalities being greater than or equal to, less than or equal to, okay? So we start by just solving them. It says the same rules apply as equations. When you're, solving, you work backwards. All those things are the same except for 2 cases, and that is when you divide or multiply both sides of the equation by a negative number. If you had something like 2x is less than 11, and let's say the 11's negative, and I divide by a positive 2, nothing changes. But if I had negative 2x is less than 11, and I divide by a negative, now my sign flips. So if I divide or multiply by a negative number, my sign changes direction. Be careful to make sure it stays in or equal to or not or equal to, so just the direction of it changes, not anything like that. The answers can be in an inequality statement, and then you'll graph the interval notation. So you'll see when, I'll show you both ways on the answers in the notes. But on the test, it's going to ask you to put it in interval notation. So you want to be practicing that stuff, okay? And this is interval notation. So interval notation is just another way of writing an inequality, okay? It's showing what the values can be. So if you had x is greater than a number, so let's just say this is like x is greater than 2. We're just going to use something random the whole time. I'm going to, on my number line, plot 3 numbers with that one being the middle, so I establish direction. So 2's in the middle, and then I go 1, 2, and 3. So you want to do 2 to either side to make sure you're showing that the number line goes in the right order. And then if it's greater than, normally we would get an open dot. You guys remember this, like an open dot and a closed dot? Does it sound familiar? And you would shade in the direction you're going to go. Interval notation uses a parentheses to represent open dots and brackets to represent solid dots. So what used to be an open dot now gets a parentheses, and what used to get a solid dot now gets a bracket. So I would put a parentheses here on the 2, and then I would shade everything to the right-hand side because that would be greater than. So that's the graphed answer, and then the actual interval notation is that without the graph. So it goes from 2 with a parentheses on the 2, and then the way we show greater than is that it goes all the way up as far as we can go, which we don't have a number. It is just infinity. So that little sideways 8, which people stress out about, don't. Okay? If you can't get a perfect little thing, put 2 little zeros next to each other. I don't care what it looks like as long as I know that's what you're implying. That means infinity. So this is basically saying starting at positive 2, but not including it, and then anything bigger than it. If it's greater than or equal to a number, so let's say it's greater than or equal to positive 2, I would do the same thing, line up my numbers on a number line. The bracket now goes on the 2, and my arrow points to the right. And then my interval notation gets a bracket pointing to positive infinity. Yep.
So the closed dot
Is like a bracket.
is like a bracket and it means equal to. Or
Correct.
Okay.
Yep. So like if it helps, like these little dashes are at the top and the bottom of your brackets, if it helps you remember that. It just means it includes that point. So in that inequality statement, 2 works. 2 is greater than or equal to 2. But in this inequality statement, in this first one, 2 would not work because 2 is not greater than or equal to 2. So that parentheses says it can't include it. It can include 2.0000001, but it can't include 2 itself. Okay, so then on the right, I'm going to go there and then I'll go to the underneath. X is less than any number, so if this said x is less than 2, I would do the same 3 numbers, 1, 2, 3. There's a parentheses on the 2. This time it points left, so my parentheses goes in that direction. So now it's less than it. Everything less than would be left of that number. And if positive infinity is the greatest number you know, what do you think the smallest number you know? Good. So this goes negative infinity up to 2 with a parentheses on the 2. So the infinity basically goes where the arrow would go. If it was x is less than or equal to a number, so let's say x is less than or equal to 2, I would do the same thing. 1, 2, 3, less than or equal to now gets a bracket, and I would point it less than, which is left. This would be negative infinity to 2 with a bracket on the 2. Justin.
So the parentheses is always where the arrow is.
Well, the parentheses is always on infinity because you can't include infinity because it's not a number. So infinity and negative infinity will always get a parentheses, never a bracket. But the bracket goes with the or equal to, and the parentheses goes with the not or equal to. Sophia.
So you can switch the 2 numbers in the parentheses, right? Like the 2 and the negative.
So those parentheses, you always want to go in sequential order. So the negative infinity will always come first. So it's always smaller number to bigger number. It needs to stay in that order. All right, so then let's say we've got a compound statement. So the next ones would say, the first ones are and statements. A is less than x, which is less than b. Or x is greater than a and less than b. So this could be a statement like negative 2 is less than x, which is less than 2. That's what that could look like. So I could do negative 2, negative 1, 0, 1, 2. As long as you have 3 of those points, you don't have to have all of them. And they will each get parentheses because it's not or equal to, and I will shade in between. So that statement says it starts at negative 2 but can't include negative 2, and it goes up to 2 but can't include it, and then it's everything in between. So then my interval notation is negative 2 to positive 2, and it looks like a coordinate point, but that is interval notation. They both get a parentheses.
It doesn't always have to be 2, right?
No, yeah, no, I just threw numbers out there. You'll see they'll change.
So it could be like negative 4 and 4.
Sure. It could be negative 4 and 10. They don't even have to be the same number. Yep. Okay, then we get less than or equal to and in between, right? So this could be negative 2 is less than or equal to x, which is less than or equal to 2. So I could do the negative 2, the positive 2. I could put just 0 in between. Brackets on both of these this time, shaded in between. So I'd get negative 2 to positive 2. The last two are or statements. So x is less than a or x is greater than b. In order for these to be statements that work, this would have to be less than, like let's say it's less than 1, or it would have to be greater than something greater than 1. So you can't have, like I'll show you what happens if it's an overlap. But let's say it's less than 1 but greater than 3. So I can do 1, 2, 3. And the word or, if you think about the oars on a boat, they will always point out like that, okay? So if it's less than 1, it points like that, or greater than 3, it literally points in those directions. So an answer like number 2 would not satisfy this because 2 is not less than 1 or greater than 3. But anything else would. In interval notation, the arrow would be the negative infinity up to the 1, and then it gets a parentheses. And then we put a little u to represent or. It's union, but it represents or. And then 3 to positive infinity. Let me make sure WebAssign does the u. Sometimes they do a comma. So then the last one is like x is less than or equal to 1, or x is greater than or equal to 3. This would be that 1, 2, 3 bracket on the 1 pointing to the left for less than, bracket on the 3 pointing to the right for greater than, and then it'd be negative infinity to 1, union 3 to positive infinity. God bless you. So every question that we answer today, we're going to also do an interval notation to practice it, okay? You can have a mix of greater than and less than, and greater than or equal to, less than or equal to. Meaning I could have something that says x is less than or equal to 0, or x is greater than or equal to 4. Actually, that doesn't serve the purpose. Greater than 4, let's say. So this means I'd have the 0, I'd have the 4. The 0 is going to get the bracket, but the 4 is going to get the parentheses. It can be mixed like that. So then I would say this is negative infinity to 0 with a bracket, and then 4 to positive infinity with a parentheses. So just be really careful. It can be mixed like that. Yep.
And how come there's not a bracket like for the left of the infinity?
Because infinity is not an exact number, you can never include it. So it will never get a bracket. Negative infinity or positive infinity will never, ever, 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 ever get a bracket. Because you're saying I can include 0, and there's no such thing as infinity, right? It represents going on until infinity, but there's not an actual number that is infinity. Yeah.
So on the other ones, the same thing, like up there?
Yeah, so like if I had, you mean that they could be mixed signs?
No, like that way you put a parentheses next to infinity.
Like I could have, yeah, oh, forever. No infinity will ever have a bracket. Is that what you mean? Yeah, never. All right, so we're going to solve these. Okay, they are obviously inequalities. We're going to solve them, and then we're going to plot them on our number line and show interval notation. So number 1 says 5x minus 7 is greater than 3x plus 9. I can subtract the 3x from both sides. 2x minus 7 is greater than 9. Add the 7. 2x is greater than 16. Divide by 2. X is greater than 8. So I'm going to graph it. There's my inequality statement. My graph would be 7, 8, 9. Parentheses or bracket. Parentheses pointing right or left? Right. So greater than points it to the right. It'd be 8 to positive infinity with a parentheses on each. Go to 2. 7x minus 3 is less than or equal to 2x plus 7. Subtract the 2x. 5x minus 3 is less than or equal to 7. Add the 3. 5x is less than or equal to 10. Divide by 5. X is less than or equal to 2. 1, 2, 3. Parentheses or bracket? Bracket, left or right? Left. So I'd get negative infinity to positive 2, sorry, with a bracket on the positive 2. Yep. So it's gonna say solve like on the test, I'm not gonna make you graph. It's gonna say solve and then give it to me in interval notation. So I'm looking for this overall answer. On WebAssign, some of them say solve the inequality, then it'll say graph, and it's actually gonna give you a graph to do, and then it will say give it an interval notation. So it's got multi-part. The interval notation, it actually, let me think, see if there are any of them. They're actually writing out the word infinity instead of using the infinity symbol. So if it was negative, it would write out like negative infinity, comma, 2, and bracket and parentheses. That's what it looks like. Okay. All right, 3. What are you going to do first? Get rid of that fraction. Multiply by 2. So 2 minus 3x is greater than or equal to 2x minus 8. Make sure the 2 goes all the way across. Add the 3x. 2 greater than or equal to 5x minus 8. Add the 8. 10 greater than or equal to 5x. Divide by 5. 2 is greater than or equal to x. And if you want to flip it, make sure that the big part still stays open towards the 2. So it could be rewritten as x is less than or equal to 2. So the graph, 1, 2, 3, is a bracket on the 2 pointing to the left. And it'd be negative infinity to 2 with a bracket on the 2. Questions on that one? All right, what are you going to do first on 4? Good. Get rid of that fraction. Multiply by 3. So 6 minus 5x is greater than 3x minus 18. Add the 5x. Add the 18. Divide by 8. 3 is greater than x, or x is less than 3. On a graph, 1, 2, 3, put a actually, let me go 2, 3, 4. Put a parentheses on the 3 and point it left. So negative infinity to 3 with a parentheses on the 3. Questions so far? Okay, now we've got a compound statement with the variable in the inside. So whatever I do to isolate the variable on the middle, I have to do to both sides. So for 5, the first thing I'm going to do is add 2 to the middle, to the left, and to the right. Again, whatever you do to the middle, you got to do to both sides. So I end up with negative 2 is less than or equal to 5x, which is less than 9. Divide everything by 5. And I get negative 2/5 is less than or equal to x, which is less than 9/5. So I'm going to draw my number line. I'm going to go negative 1, 0. This would be 1 and 4/5. So I'm going to go 1 and 2. I know I'm in between 0 and negative 1. It doesn't have to be perfect, but a little bit past it. Let's say that's negative 2/5. And then 1 and 4/5 would be close to 2, but it doesn't have to be perfect. A bracket goes on the negative 2/5, a parentheses on the positive 9/5. And in the interval notation, this is negative 2/5 with a bracket on the 2/5 to 9/5 with a parentheses on the 9/5. Samuel. This, 1 and 4/5. I just put it in mixed number form. Like 9/5. Yeah. Just so I knew where to graph it. Still good? Yeah? Okay, 6. Add the 1. Add the 1. Add the 1. Negative 2. Less than or equal to 6x, which is less than 4. Divide by 6, divide by 6, divide by 6, negative 1/3, less than or equal to x, which is less than 2/3. Negative 1/3 gets the bracket, 2/3 gets the parentheses, and we shade in between. Seven. Negative 6, less than 2x, which is less than 4. Divide both sides by 2. Negative 3 is less than x, which is less than 2. Parentheses on each, shaded in between. All right, what are you going to do for 8? Multiply everything by 3. I get negative 12 is less than or equal to 2 minus 3x less than 15. I'm going to subtract 2. Negative 14 less than or equal to negative 3x, which is less than 13. Divide by negative 3, which causes what? Good. So I get 14 over 3 is greater than or equal to x, which is greater than negative 13/3. Notice if it was or equal to, it stays or equal to, and if it was not, if it was like just less than, it stays that way. It just flips the direction. So think about what that statement says. That's basically saying it's less than 14/3, but greater than negative 13/3. If you want to flip it so it matches your number line, go ahead and do that. The smaller one should come first. The big part of that inequality still opens towards the x, and then it's 14/3. So on my number line, I can just do the negative 13/3 and the 14/3. The one on like WebAssign actually has the numbers on it, so don't stress about it too much, putting all the stuff in between. This is going to have parentheses. This is going to have a bracket. You're going to shade it in between. Just be careful with your brackets and your parentheses. Okay, yep. Okay, so now we're combining absolute value with inequalities. A little bit of what we did yesterday with what we did started today. You're going to start typically the same way, which is to isolate the absolute value, okay? But then there are two things happening. If the absolute value is less than or equal to a number, it becomes an and statement. So if you literally think less than, it kind of ends with an en. If you change that to an, it's and. If the absolute value ends up being greater than or equal to something, it becomes an or statement. So think great or, it actually ends in the same sound. Great or becomes an or statement, okay? So this is one of those things that you have to know to do. It's not like it's going to happen if you don't know to do it. You have to split it, okay? So you're going to first, this is important, isolate the absolute value. If there's a number added to it or subtracted from it, you have to move it. If there's a negative on the front, you have to divide or multiply by it. Then once the absolute value is on the side by itself, if it's less than or equal to a number, you're changing that to an and statement. God bless you. If it's greater than or equal to a number, you're changing it to an or statement. So it looks like this. 9, absolute value of x minus 5 is less than 2. Absolute value is already isolated, right? So if it's less than, it becomes an and statement. I take the 2, I make it negative on the left side of my inequality sign. I make the less than look like it's going in the same direction that was originally there. So whatever this direction is what you want to make the new one. So if it's less than a number, the opposite of that number goes to the left. Keep the absolute value going, keep the inequality going in the same direction, and then solve it. So I'm just going to add the 5 in all 3 spots. And I get 3 is less than x, which is less than 7. My number line, 3 and 7, parentheses on both, shading in between. Interval notation would be 3, 7 with parentheses on both. Ten says absolute value of x plus 3 is greater than or equal to 7. Great or is or. So I do almost the same thing. I make a negative 7. I make the sign going in the same direction. I finish my inequality statement. But then I stop and I put or, and then I finish what's already there. So these are 2 separate statements. So great or we split. Then solve it. Negative 3. So negative 10 is less than or equal to x. Minus 3. X is greater than or equal to 4. If you want to flip this so it makes sense, it would be x is less than or equal to negative 10 or x is greater than or equal to 4. So on my number line, I do the negative 10 and the positive 4. It's greater than or equal to, so it's a bracket. And the ors point out like a boat. And the U on WebAssign is a semicolon. It tells you to separate it with a semicolon. Okay, instead of a U. On the test, I'll take either one. So like if you get accustomed to doing the semicolon, that's fine. All right, so 11, it's already isolated. This is x is less than 20, which is less than or equal to 4. What does this become? An and or an or? And for me, I sometimes have to read it. I know I don't want you in the middle of your test start reading these things out loud, but sometimes I'll read it in my head. That is less than. So less than is and. So this becomes negative 4 is less than or equal to x minus 20, which is less than or equal to 4. And then add the 20. So I'd get 16 is less than or equal to x, which is less than or equal to 24. Number line, just do the 16 and the 24. You don't got to do all the stuff in between. Bracket on each, shaded in between, and my interval notation looks just like that. 16 to 24 with a bracket on each. So 12 is the perfect example of why you cannot make the decision on if it's and or before you isolate. Because when I divide both sides by negative 3, it flips my sign to a less than. So initially it was greater than, that would make you think that it's or. but then it's truly less than. You have to wait until, where did my minus go? You have to wait until after you isolate to decide. So now it's less than, again, it's an and statement. -5 is less than or equal to x minus 1, which is less than or equal to 5. Add the 1 in all 3 spots. -4 less than or equal to x, which is less than or equal to 6. -4, positive 6, bracket on each, shaded in between. All right, now these, I'll explain it while we go, but these are important because there are special cases to these absolute value, if you think about it, okay? So if I have the absolute value of something, and it says it's greater than or equal to a negative number, what's true about that? It would be all real numbers, good Isabella, because the absolute value of anything is either going to be 0 or greater than 0, right? And those things are always going to be greater than or equal to a negative number. So I'll show you the other way around it when you go to graph it. But this would be an all real number scenario. All real numbers is -infinity to positive infinity in interval notation. So all real numbers, -infinity to positive infinity, okay? If it said the absolute value of something was less than or equal to a negative number, what's true about that? No solution. So you would literally write no solution there. Interval notation does not get anything because interval notation is showing you what it can't be, and it can't be anything. So on web assigned for homework for these, you'll leave the blank, like you'll leave the graph blank and you'll write no solution. I think it says the words no solution, okay? But again, when you go to graph this, it should happen. Like hopefully you catch it and you eliminate a lot of work, but if not, you'll catch it. So like look at 13. Divide both sides by -2. And I get absolute value of x minus 1 is now greater than or equal to -2. Now based on what we just said, what's true about this? This is all real numbers, right? Everything would be greater, everything out of absolute value would be greater than or equal to -2. But let's pretend we don't know. It's a greater than statement. So I would tack the opposite of what's there to the other side, and it would be 2 is greater than or equal to x minus 1, or, because it's an or statement, x minus 1 is greater than or equal to -2. So I add the 1, and I get x is less than or equal to 3, and I add the 1, and I get x is greater than or equal to -1. Draw your number line. This would be x is less than or equal to 3 if I put it in order. I'd get -1 and I'd get positive 3. Less than or equal to 3 is what? If I just graph that part. What would x is less than or equal to 3 look like? It's a bracket on 3 and it points to the left. I didn't get it exactly on 3, but you get the point. X is greater than or equal to -1 would look like what? Bracket, yeah, sorry, you're right. Bracket to the right. So what did I just do to that number line? It's all of it. I shaded the whole thing. Okay, that's in all real numbers. So all real numbers would be a arrow in both directions or a -infinity to positive infinity. You get to catch it here and save yourself some work. Just be careful. Or if you second guess yourself, you can always solve it and check it. So 14 less than or equal to 0. Sorry, go ahead.
Would it be with brackets because it's like the greater than or equal to, or does it not?
An infinity can't have a bracket. So if all real numbers will always have parentheses.
Okay.
Yep. Okay, look at 14. Absolute value of something is less than or equal to 0. So what's true about absolute value? It's got to be positive, right? Can it ever be less than or equal to 0?
Or it can be equal to 0.
It can be equal to 0. So this one's tricky because the only value that's going to work is if whatever's inside the absolute value is actually equal to 0, which means my only answer is the number 1. Okay? If you catch it, you just eliminated a lot of work. If you didn't, I would continue to work through this. So that is less than 0. There's only thing opposite of 0 is still 0. Would be less than or equal to x minus 1, which is less than or equal to 0. I'd add 1. 1 is less than or equal to x, which is less than or equal to 1. So there is no arrow going in any direction, but there is a bracket on 1, which means 1 is the only answer that works. So your answer would literally just be 1, and on the number line on Canvas, on WebAssign, it would just get a dot. You'd put a solid dot on 1. So if it's only one answer like that, it gets a dot. Yeah.
It's only one answer when I have a 0.
Well, it's either one answer or it's no solution. If that said less than and it didn't say less than or equal to, then it's no solution. If it said greater than or greater than or equal to, it's all real numbers. Does that make sense? Yeah. Actually, greater than or equal to would be all real numbers. Greater than would not be. Greater than, you'd have to solve it. Okay, so this is what I just said, right? Absolute value of 2x minus 1 is less than or equal to 0. Can't exist, except for which value? Equal to. So again, if you catch it, you eliminate yourself a lot of work. Just do the 2x minus 1 equals 0. 2x would equal 1, and x would equal 1/2. 1/2 is the only answer that works for this. If you don't catch it, 0 less than or equal to 2x minus 1, less than or equal to 0, add the 1, add the 1, add the 1. Divide by 2. And because it's or equal to, that is the only value that works. If it was less than and not less than or equal to, it would be no solution. The equal to is the only reason that there's a solution. And then 16. What kind of numbers are greater than 0? All real numbers, right? Except the only one that's not counting this time. 1/2. Does that make sense? Because it's not or equal to, okay? If you don't catch it, 0. This is greater than. So greater than 2x minus 1 or 2x minus 1 greater than 0. Add the 1. Divide by 2. So x is less than 1/2. Add the 1. Divide by 2. Or x is greater than 1/2. So this is basically saying every single number except for 1/2. Because it's not or equal to. In interval notation, that is negative infinity to 1/2, parentheses, union or semicolon, because that's what WebAssign's going to do, 1/2 to infinity. So that is every number but 1/2. If it was greater than or equal to, it's all real numbers. But because it's greater than and not greater than or equal to, it's all the numbers except 0, or what would make it 0, which is 1/2. Do me a favor, just go to WebAssign real fast so you can practice the graphing on the number line, and let's make sure it's not glitchy.